Today we will discuss motion on a plane. Motion of what? Motion of object or particle. An object is consisting of large number of particles. But for simplicity, we will first consider the particle. So before going to the motion in a plane or on a plane, we have to identify the position. We have to identify the position of a particle. In a plane, when we in a plane, we find out the position of a particle. We have to represent the position in terms of its position vector. So, in order to find out the position vector of a particle, we can take two coordinate axes. Suppose this is your x-axis and this is your y-axis in a plane, and this is your 0, origin O. So suppose there is a particle here, P here, the particle P is located at this point, and what is the position vector of this line joining the point P with this? This is the position vector of the particle P. So let this position vector be R1. That means your OP is R1. OP is your R1. Similarly, another particle Q here, or same particle moves in this position like this. So this is your Q. So at this position with time, so it is displaced. So this is suppose say Q. So this is suppose say over R2. This position vector is R2. So what is the displacement of the particle? Displacement of the particle is this. So that is your PQ. So here it constitutes a triangle. So in the triangle, we can apply the triangle law here. That is your PO plus OQ is equal to PO plus OQ is equal to PQ. Equal to PQ. So what is PO? PO is for R1. What is OQ? That is R2. Right. This is R2. And what is your PQ? That is your, suppose say, delta R. So you can find out what delta R is equal to your R2 minus, this is minus, OP is R1, PU means negative of R1. That is R2 minus R1. So delta R is equal to R2 minus R1. So when there is a change in position of the body, displacement occurs. When there is a change in displacement of the change in position of the object or particle, displacement occurs. Displacement occurs. What is displacement? Change in position, difference in position vector. So that means your what is displacement is nothing but displacement is equal to final position minus initial position. Position. Position means position vector. Initial position vector. Final initial position vector. That means your delta R, that is equal to R2 minus R1. This is the expression for displacement in a plane. On a plane. So more elaborately, it will discuss this thing. Suppose this is a now discussing elaborately. XO, X dash, YO, Y dash. Suppose this P point is located here at the point x1, y1, and Q is located as x2, y2, coordinate is x2, y2. So if we join this is OP and this is your OQ. So this is your R1, this is R2, this is your PQ, this is your PQ. Suppose this is R. So what is R is equal to? Here the R is equal to your R2 minus R1. So what is R2 is equal to? R2 is equal to, in terms of rectangular coordinates, the vectors will be, corresponding unit vectors will be x1 I cap plus y1 j cap. This is your R1. R1. Similarly, R2 will be x2 I cap plus y2 j cap. So here R is or R2 minus R1. R1. That means this is equal to x2 I cap plus y2 j cap minus x1 I cap plus y1 j cap. So this is equal to x2 minus x1 I cap plus y2 minus y1 j cap. So if this initial P will coincide at the origin. Then what will be the coordinate of P? P would be 0, 0. That means x1 will be 0 and y1 also 0. So if the point P is at origin, then P, then coordinate is your 0, 0. P of 0, 0. This means in that case, x1 is equal to 0 and y1 is equal to 0. In that case, what will be R? This R will be under x2. At the time x2 can take x and x2 will be x and y2 will be y. So that case we can write x is equal to x I cap plus y j cap. So this will be displacement when the one point is origin. Then this ultimately this displacement. So if the particle moves like this, it is at time t1, it is at time t2, reaches here at the time t2. Then what is the difference in time interval? The difference in time interval is t2 minus t1. So that can be represented delta t. So for delta t is equal to t2 minus t1. T2 minus T1. So from the expression also we can find out what is the velocity. The velocity will be here velocity velocity on a plane on a plane in two dimension. Plane means two dimension. So that will be what is the velocity? The definition we have already read in straight line motion. So it is defined as rate of change of position vector of the body with time. It is the rate of change of position vector of the body, position vector of the body with time. Here, what is your v? And that velocity is called average velocity. V, v is your delta r by delta t. So this is v average. This is called, this v is called average velocity. Average velocity. So at any time, if the displacement is equal with equal interval of time, this voltage, this velocity is called constant velocity or uniform velocity. So if it is varying, this velocity is varying, then we can Find out another term, that is v instantaneous velocity, that is equal to limit your delta t tends to 0 of delta r by delta t, that is equal to dr by dt. So v instantaneous, is equal to dr by dt. So this is the instantaneous velocity. The velocity of time, velocity of the particle changes with time. That at any instant of time we can find out the instantaneous velocity. That is p instantaneous dr by dt. That means at any small interval of time, that time tends to 0. In that case, in that ideal case, we can find the instantaneous velocity. So two terms here, this average velocity and instantaneous velocity. Okay, this much for today, and we'll continue this class in the next.